Hello again, and welcome back to Pre-Algebra with Miss Betsy. I'm glad you have joined us as we continue our discussion of how to translate English expressions into algebraic equations so that we're able to solve real-life word problems. If you're using the same text that I am, we are in Chapter 8, Section 2 of Pre-Algebra for Christian Schools, first edition. It is published by Bob Jones University Press. As always, you don't have to use the same text that I'm using. This is just basic elementary information that will teach you how to better understand how to set up an algebraic equation to solve a word problem. For this text, however, we are on page 255. Now, before I get going, I'll let you know that our dog had puppies last night. She is a Rottweiler Australian Shepherd cross. So if you're in the Dallas-Fort Worth area and would enjoy a lovable puppy, they will be available about the end of March 2013. Shameless plug for these pups that I would prefer to be able to give to get rid of with very little difficulty. Anyway, our question for today, our lame joke for today is, where does Friday come before Thursday? In the dictionary. Only place that I'm aware of. So, moving right into our discussion today, and this really is not going to be very lengthy at all. We've had practice already where we're just taking bits and pieces of English words and translating them into algebra, seeing what operation we're talking about. If we, for example, if we hear increased by, you know, we're talking about multiplication. If we hear less than, it's subtracted. If we hear more than, we're talking about addition. We know that is represents an equal sign. If we say the sum of a number, which can be x, and 2, the sum of a number x, and that indicates addition, and 2 is 7, that very easily translates into a number x plus 2 is 7. So this is what we're going to be discussing a little bit today. We'll see some basic expressions that you translate into algebra. And we're also going to see that there are two particular word expressions that we're going to have to be very careful about when we interpret those and translate them into an algebraic equation. So let me go ahead and look directly. Apparently that marker doesn't fit very well in there. Directly on page 255, it says you can translate written expressions involving a combination of operations into an equation. Study the following example. The written sentence that is given to us is the sum of 3 times a number, provided that I could write number properly, the sum of 3 times a number and 7 is 19. Now this one right here is very similar to the example that I just used where we said a number and 2 is equal to 7, I believe was the example that I pulled up. Right here we have the sum of 3 times a number and 7 is 19. So let's look at this expression and see what it is that we're talking about. Go through these words. Well, what does it mean when we're talking about sum of? Yes, that's correct. Sum of means addition. So we know we're going to have two quantities that we're adding together. What does 3 times mean? Well, what's it talking about when we're talking about times? Multiplication. So we're going to multiply here. Now we're talking about a number. Are we talking about a specific number here? No, this is just any number. So this is what we call our unknown, and this is what's going to be our variable. So this, a lot of times in beginning algebra books, they'll take the first letter of the word to use as your variable. So perhaps your book will tell you that we're going to let the letter N represent the number that we're trying to figure out. Sometimes people are just used to using X for it. You can use any letter at all that you would like to use to represent this unknown. What do we have now? We have the sum of, so we know we're going to have an addition problem, 3 times a number, and that's where our addition is. So we know that's going to be addition again. 7 is 19. Now, always and forever, when you see the word is in a mathematical situation, you can always know immediately that that is what's going to be represented by, that's going to translate directly into an equal sign. Okay, so now that we've looked at this, we see the sum of 3 times the number and 7 is 19. We see that we have addition, we have an unknown quantity, we have 2 things that we're adding together. We're having 3 times a number and 7. So let's go ahead and set up what our unknown is going to be. Let's just say let N equal the number. Okay, if N by itself is the number, what would be 3 times the number be? 3 times a number. Well, 3 times a number is what we're going to be looking for. 3n. N is the number. 3n is 3 times the number. So we see in our problem here, this is talking about the sum of 3 times a number and 7 is 19. Let's go ahead and put our symbols in here. What is and? And is addition. 3 times a number and 7 is 19. This is all we're talking about here. You need to look at the problem that's been given to you. Look at the English and translate this into an algebraic expression. Sum of means that we're going to add. What are we going to add together? We're going to add 3 times a number. So we're going to have n, or x, or q, or whatever letter you wish. We're going to have n represent the number, so 3 times n is 3 times the number. What sum do we have? What are we combining together? We're combining together 3 times the number and 7. When we add those together, what value do we arrive at? We say that that's equal to 19. So this is the algebraic translation of this English sentence up here. And these may be very easy for you to begin with. They may be a little bit challenging. They may make you want to tear your hair out, depending on how quickly you can, it makes sense to you to do that translation. But I can promise you that the more effort that you spend translating from English into algebra, the easier it's going to be, and the better you'll do in your classes. Okay. Now, sometimes when you're writing mathematical sentences, you have to reverse the order of the English to make your statement correct. Let me show you one. It's example 2. Now let's think about if we add 3 plus 7, 7 plus 3, we end up with the same result, don't we? It's equal to 10. But what happens if we say 7 minus 3 and 3 minus 7? Do we get the same result? No, we don't, because 3 minus 7 is a negative 4. 7 minus 3 is a positive 4. We see that subtraction is not commutative, so that's why order is important, particularly when we're talking about a subtraction problem. We're being asked here to write an equation that says 12 less than 5 times a number is 33. 12 less than 5 times a number is 33. I believe I said this was example 2. It's actually example 1. Number is 33. Okay, subtraction, the order matters. You have to think, what are you taking a quantity away from? 12 less than 5 times the number. What are we starting with? That's what you have to look at for your subtraction problems. What are you beginning with? Here, we are beginning with 5 times a number. And then we want to find out what 12 less than that 5 times a number is. So we can say let n represent the number for which we are looking. So if n is the number, what would 5 times the number be? Yeah, it would be 5n. 5 times the number. Now let's look back up here at a problem. 12 less than 5 times the number is 33. Equals 33, correct? Equals 33. Less than, of course, is talking about subtraction. We begin with 5 times a number, and we subtract 12 from that to say that we end up with the difference of 33. And you'll remember the difference is the solution to a subtraction problem. Now, what might you be tempted to do with this equation if you weren't paying attention to what's being said here? Yeah, that's exactly what you would do. You would say 12 less than 5 times a number is equal to 33. And you see this right here. We have 2 totally different expressions here, and I illustrated it by telling you and reminding you that 10 minus 4, 4 minus 10, I don't think I used those numbers, but the same thing. 10 minus 4 is 6, 4 minus 10 is a negative 6. So order is important. Actually, order is not only important, order is essential when you're working with subtraction problems. And there's a thing that I just want you to memorize. If it says less than, we're going to read it backwards, because there is a big difference between less than and less. And this is something that if you just memorize it, for now, I hate to tell you, just memorize it, but just memorize it for now and play with it. And then it will gradually begin to make sense to you. Or maybe it'll make sense to you right away. 3, let me not do that. 5 less than 7. Five less 7. Okay. 5 less than 7. What are we beginning with? John has 5 cars less than Matthew does. Matthew has 7. John has 5 less than that. John has 2 cars, correct? So we're going to begin. You have to think about what are we beginning with. We're beginning with 7, and we're subtracting 5. 7 minus 5 is 2. This one right here, 5 less 7. Here they're using a strange way of saying I was saying 5 minus. So this time, we are actually going to go directly in this order. We're going to say 5 less 7 is equal to a negative 2. What are we beginning with in this second expression? We're beginning with a 5. So what I want you to do, this is one way to look at this and say, okay, it's 5 less than 7. What am I beginning with? I'm beginning with 7, and I'm saying 5 less than 7 is 2. Here, I'm beginning with 5. I'm subtracting 7 to get a negative 2. Now, let me show you what I do. Some of you love this idea. Some of you don't. I don't care which way you use to jog your memory. But when you have less than or more than, I'm going to put this little asterisk over here, write the equation in reverse. And let me illustrate reverse. 7 less than 5. Pretend you're writing Hebrew. 7 less than 5. What are we beginning with? 7 less than 5. Okay, did you see what I just did? I changed my problem. This is the correct way to write 7 less than 5. But let's go ahead with the problem that I have actually written here on the board. What does this say? This says 5 less than 7. 5 less than 7. See, if I wrote this in reverse, almost, as if I were reading Hebrew. In Hebrew, you read right to left. What are we beginning with? We're beginning with 7, and we're subtracting 5 from it. But if we want to read the exact order here, 5 less than 7. If you have less than or more than, and you can write that equation, write that expression in reverse, 5 less than 7. But it's only when you have less than or more than. Those are the only times that you can do this. Less than, more than. They have another example in your book here. It says, this one is addition. Bill's age of 21 is 3 more than twice Jan's age. Bill's age of 21 is 3 more than Jan's age. Doesn't look like that orange is showing up particularly well. Bill's age of 21 is 3 more than Jan's age. What does this ask us to find? It says, well, we want to find out what Jan's age is. Write an equation. Bill's age of 21 is 3 more than twice Jan's age. Make sure that you take the time to verify that you've written the problem correctly. It's 3 more than twice Jan's age. We have an is, which is the equal sign. We have 21, that's what we're going to have. An expression is equal to 21. 3 more than twice Jan's age. 2 times Jan's age, so why don't we just say let x equal Jan's age, or let j equal Jan's age. If x is Jan's age, if x is Jan's age, how would you indicate twice Jan's age? 2x. Okay, 3 more than twice Jan's age. What are we beginning with? We're beginning with twice Jan's age, and we're adding 3 to that to say that we have 21. You're going to see that Jan's age is actually 9, but we're not solving the problem. We simply want to be able to come up with an algebraic equation that we can solve. Bill's age of 21 is 3 more than twice Jan's age. So I wrote this expression left to right, didn't I? I looked at my problem and I said, what am I beginning with? Well, I'm beginning with twice Jan's age, and I'm adding 3 to that. But if you look at this, you might be tempted to say 3 more than twice Jan's age is equal to 21. Because you're reading it exactly in the order in which it's given. Now with addition, is that answer truly the same? Yes, it is. It has the same value because addition is commutative. It's the same answer no matter which order you have those add-ins in. But I want you to get in the practice. I want you to practice and get in the habit of writing exactly what has been said here. So what did we begin with? We began with twice Jan's age and we added 3. But here we have another, we have more than. When we have more than or less than, we can write that expression in reverse. 3 more than twice Jan's age is 21. You see that I came up with identical equations like I have to if it's going to be correct. But here, what am I looking at first? What am I beginning with? I'm beginning with twice Jan's age, and I'm adding 3. Here, I read the expression, wrote the expression in reverse, and I said 3 more than twice Jan's age is 21. Whichever one of those two ways makes the most sense to you when you're translating, go ahead and use it. It makes no difference at all what your reasoning process is. It just has to be a true thought process. So let's go ahead and look at the skill check on page 255, and I want to talk about number 1. 4 times a number decreased by 7 is 65. So we have 4 times what? A number decreased by. What does decreased mean? Well, we're subtracting. Decreased by 7 is equals. Is 65. The one step that I left out at the beginning, we didn't say let n equal the number. Okay, so if n is equal to the number, then 4n, of course, is going to be equal to 4 times a number. Our problem says 4 times a number decreased by 7 is 65. What are we starting with? 4 times a number. What are we doing? We're making it 7 smaller. Now, Tom's weekly salary, let me go ahead and do problem number 2. Just talk through this one. For students in my class, go ahead and have your book open, page 255, and look at problem number 2 in the skill check. It says the sum of 2 times the number and 3 is 17. What are we going to have be the number? Let n equal the number. Straightforward. What's our problem say? The sum of 2 times a number and 3 is 17. Sum is addition. What are we adding together? We're adding 2 times a number and 3. We see that that is equal to 17. If you have a hard time remembering that is represents the equal sign, just say the sum of 2 times the number and 3 is equal to. And then you'll not have any difficulty translating from is to the equal sign. Problem number 3 says 25 more than 7 times a number is 46. 25 more than 7 times the number. So I have more than. I'm going to write this problem in reverse. As I read it, I'll write it in reverse. Let's have n be the number. What quantity are we talking about in here? 7 times the number. So we also have 7n that we're going to deal with. Now let's go ahead and write our equation. 25 more than, so I'm going to go in reverse. 25 more than 7 times a number is 46. If that doesn't make sense, pause the video, look back, get your pencil out, and make sure that you can track along with me. Now let's look at problem 4 in the skill check. This one says, when Robert's age is doubled and increased by 6, the result is Sally's age. So why don't we say, let R equal Robert's age. Now let's see what we're going to be doing with this. Robert's age is doubled, so what would Robert's age doubled be? It would be 2 times R. When Robert's age is doubled and increased by, what does increase mean? It means addition. And increased by 6, the result is Sally's age, which is 34. The result is equal to Sally's age, which is 34. This here, when Robert's age is doubled and increased by 6, the result is Sally's age of 34. Let me do this one final example, number 5 in the skill check. Tom's weekly salary of $61 is 4 less than half of William's salary. A lot of things going on here. First thing that jumps out to me, less than. What's being compared here? Tom's weekly salary is being related to half of William's salary. So why don't we say, let W equal William's salary. Now, see what we have. Tom's weekly salary of 61 is 4 less than 1/2 William's salary. If this W is William's salary, what is 1/2 William's salary? So 1/2 times W would be 1/2 of William's salary. 4 less than 1/2 of William's salary is 61. This is the process of putting this equation together by thinking of less than and working in reverse. 4 less than half of William's salary is $61. Or you can use the thought process that says, okay, what am I beginning with? What am I taking something away from? Well, I'm subtracting from 1/2 of William's salary. So what I begin with is 1/2 of William's salary. I subtract 4 from that, and I end up with Bill, I think it was Bill's salary of $61. Give yourself plenty of time to work on these. You will gain speed and gain confidence the more of these examples you do. I will see you next time.